So in this problem, we have a vertical spring with a spring constant of 450 newtons per meters, and it is mounted on the floor, so as you can see here. And from directly above it, a 0.3 kilogram block is dropped from rest. It falls down and it collides and sticks to the spring and compresses it by 2.5 centimeters. Assuming air resistance is negligible, from which height above the compressed spring was the block dropped? So obviously here we need to study a conservation of mechanical energy. We have no resistive forces, so it makes sense that the mechanical energy is conserved. We will consider the initial point, right where we dropped the block, and the final point where the block made this maximum compression. And in the conservation of mechanical energy, as usual, we take the kinetic energy, including translational and rotational terms. We take the gravitational potential energy and the elastic potential energy. Now, since we have no rotation, then these terms will cancel out. Half I omega squared will cancel out. And we also know that V final is where we have a maximum compression, and it brings the block to a momentary halt. So it's at rest at this final point. So the speed is 0 here because the block comes to rest. So we have no translational kinetic energy as well. Also, at the initial point where we drop the block, we are told that the block is dropped from rest. So the initial speed is also 0, and this term also cancels out. And we are left with these three terms: mgh final plus half k y final squared is equal to mgh0. Note that here the elastic potential energy, which is half kx squared, is written as half ky squared because we have vertical displacement, so it's more convenient to write y instead of x. Now what we want is this h. Now if the initial height of the block was h0 and the final block is h final, then h is obviously the difference between them. So h is h0 minus h final. So we can rearrange this equation. If we bring this term here and this one here, and then multiply it by a minus sign everywhere, we have mgh0 minus h final is half k y final squared. We substitute this with h, and now we have this equation for h, and all we have to do is just substitute. We have k is 450. Y final is the final compression of the spring, which we are told is 2.5 centimeters. We will write this in meters, of course. Now, if you leave this in centimeters, your height will be in centimeters as well, which is fine. Sorry, I forgot the 2 here from the half. So we have 2 times the mass, which is 0.3 kilograms, times gravity, which is 9.8. And then we get a height of 0.048 meters or 4.8 centimeters, from which we have dropped this block.